So the formula for the volume of a pyramid is 1/3 times the area of the base times the height. So we need to be able to recognize what the base is in the picture. And once we identify the base, then we can use this formula, which is provided on your reference sheet, to figure out the value. So if we look at our first picture here, I wish the picture was a little bit better, and overall this picture is okay. But it says, determine the volume in cubic units of the following pyramid. And what we need to look at here is we need to look at the fact, first of all, that this is coming to a point, so it is a pyramid, which already says in the directions in this particular place, at some point in time, we're going to have to be able to recognize what is the figure, and then what formula do we use. Down here in the base has a length of 6, and it has a width of 4, and this pyramid is really a rectangular pyramid. But once again, it's not the best picture because I couldn't get the right angle in right there. But if you look to the left on your green reference paper, we also have how to find the area of a parallelogram formula, because eventually what we're going to fill in is we're going to fill in 1/3 times the area of the base times the height. And the area of a parallelogram, which also is qualified for a rectangle is a parallelogram, the formula for that is base times height. So if we look at this shaded portion, and let me highlight it for people watching the video, there's the base, and it's shaded, and you can see that on your paper as well. We're going to take 6 times 4, which is 24, and that's the area of the base. And then we're going to take that value, we're going to put it back into our pyramid formula. And some of you are just going to do it in one step, and that's fine. I'll do some other problems with one step. But when we fill this in now, this is going to be 1/3 times 24 times the height of the figure. And we do have a good indicator of the height. The height is the 9 here. And then we take decimals. We take our calculator, and we type this in. Remember, when you're using the calculator, you don't have to have a fraction button. It's much easier on decimals, especially if you have an iPad, but you can do 1 divided by 3. There's the 1/3 times 24 times the height, which gives us 9. And when we look at that, that gives us the volume of our pyramid here. It's 72. And our units, again, when we measure volume, are going to be cubic units. Second picture, I found this one. I like it, but I also found that it's kind of hard to see the pyramid. But we do come to a point here. So there's the point. That's one of the indications that it is a pyramid. And our formula to find the volume of a pyramid is 1/3 times the area of the base times the height. I oftentimes write it down so that I can remember it later, so I don't need the reference sheet. But the reference sheet will be provided for you. But what we need to do is we need to find the area of the base here, which is shaded in for us. And if I'm looking at that correctly, and I am, that's a triangle. So the area of the base, and if we look left on our green paper, we see the formula for the area of a triangle, it's 1/2 times the base of that triangle times the height of that triangle, and we've got that right angle in there. It doesn't look like it, but it's a better picture in some regards than the first one. But when we fill this in, then to find the area of the entire triangle, it's going to be 1/2 times the base, which is 12. There's the base. And our height of that triangle is 10. See how it hits at that right angle right there? And then we're going to type that in to find the area of the base. I like to use 0.5 for 1/2, and you can still use 1/2. But 0.5 times 12 times 10 gives us the area of the base. And once we know the area of the base, we're going to take that value and we're going to put it back in here for the b. So the volume is going to be 1/3 times the area of the base, which is 60, times the height of the pyramid. Well, the height of the pyramid is 17. And then we'll type that value in either into Desmos or into the calculator, which I have up here. Once again, if you are using a calculator, you do not have to have a fraction button. It's going to be 1 divided by 3 times our 60 times 17. And then we're going to get our volume of this triangular prism because the base is a triangle. We end up with 340 feet cubed. And oftentimes that's what we're doing. We're finding the volume. But as we look to the next question here, this time, oh no, this one still says determine the volume of the pyramid below. Round our answer to the nearest hundredth, if necessary. And as we take a look here, because there's no shaded part, but what we're looking at for our base in my disoriented picture here is down here, and as I scoot that over, not much better, but a little bit better. There's the base. So we need to identify that. And what we see is, we see that one side of the base is 14, and the other side of the base is 14. And it looks like this one is going to be a square pyramid. I wish that the picture was a little bit better. I wish that that had a right angle in there. But we have to find the area of the base. A square is a parallelogram. Eventually, we're going to be using the formula 1/3 times the area of the base times the height. And the area of the base is going to be calculated with our parallelogram formula, which is based on type. So it's 14 times 14. And you can type that into Desmos, you can type it into your calculator, but 14 times 14 is 196. And once we know that, we're going to take this value and put it back into our area of a base. And you can put it in there at the start. But we get 1/3 times 196 times our height. And again, this one a little bit hard to see, but the height of our figure is this 25 centimeters. And what's going to happen on this one is we're going to get a decimal answer. So when we go ahead and type it into our calculator, again, you don't have to have a fraction button. 1 divided by 3 times our 196 times the 25. And we get here, round the answer to the nearest hundredth for our volume. And we get 1633.33. Our units are centimeters cubed. We're looking at this 3 to determine what to do to that 3. And since 3 is less than 5, that second 3 remains the same. When we flip our paper over, we see the volume of a cone formula. So you can look at your reference paper, and a cone is going to have a circle in it. I wish that I could have found a picture of it, but the formula for the volume of a cone is 1/3. The base, the area of the base, is a circle. So the formula for the area of the base is pi r squared times the height. And again, that formula will be provided for you. And now that we have that information, we're going to use it to answer a few examples. This one, find the volume of the following cones. And notice we want to leave our answer in terms of pi. So let's point out what we know. First of all, let's write down the formula. Pi r squared h. And what I see in this problem is that the radius is 7. But watch out, sometimes we're given diameter, but in this particular case, from the center to a point on the circle, that's the definition of radius. And then our height is the 12. And now that we know that, we can fill these values in through a formula. It's 1/3 times pi. We're not going to multiply by pi this time. We want to leave pi as part of our answer. Times the radius squared, which is going to be 7 squared. Times the height is 12. So when we're typing this in, what I'm actually going to type in is I'm going to type in 1/3 times 7 squared times 12. And then I'm going to leave the pi. Try to leave a little bit of space there, but I'll try to separate it. So typing in the numbers, leaving pi alone, that's going to give us our volume when we type it in. So pulling up the calculator, 1 divided by 3 times 7 squared times 12, that out eventually. We get 196. So our volume is going to be 196 pi. Our units, again, volumes measured in cubic units, so this is feet cubed. But watch out. Are you given the radius, or are you given the diameter? That's the key. When we look at this next example, what we see is we are given the diameter in this particular picture. The 14 goes from one side of the circle to the other side of the circle, which is the definition of diameter. Goes through the center. So our radius, the relationship between the radius and the diameter is that the radius is half as big as the diameter. So this is going to be 7. And now we can, we've got the information we need because we've got the radius. The height in our picture here is 18. And we can fill in our formula. And the formula is 1/3 times the area of the base times height, which I got that wrong there, but it's 1/3. It wasn't really wrong. The area of the base is pi r squared because it's a circle times the height. And that's one of the ways. Do you have a circle in the problem, or do you not have a circle in the problem? If you have a circle in the problem, it's either going to be a cone or it's going to be a cylinder. And then if you have a point to it, then it's going to be the cone. We fill in our information here. 1/3 times pi times the radius times the height. And not going to be much different from the last one because we ended up having the same radius on letter B that we had on example A. When I type this in, I'm going to type in 1/3 times 7 squared times 18. And then we've got our pi over here. Separate that. One divided by 3 in parentheses times 7 squared times 18 gives us 294. So our volume is 294 pi. Our units, feet cubed, again, volume measured in cubic units. And just want to scan this into the document here. There's how we got that. Once you know the formula, the problem isn't too difficult, I hope. I do recognize that for some, math is always difficult. It doesn't matter what we're doing. But if we take a look at example number 4, what we can see is we can see the height of the cone. And we can see a distance on kind of the side of the cone. But what we don't have in this particular problem is we don't have a radius or a diameter, as the case may be, in this particular problem. So we have to find it this time. And you probably won't be surprised to know that we have to use a Pythagorean theorem. Our radius is here. It goes from here to here. And again, we're going to use the Pythagorean theorem. Recognize that here is a right angle, a big right angle because the board's disoriented. But this is going to be r squared plus 15 squared equals 17 squared. The 17 is the hypotenuse. It's across from the right angle. And when we type this in, we get r squared plus 225 equals 289. Again, use your calculator, use Desmos, just trying to save a little bit of time from that standpoint, from typing it in. We can subtract 225 from both sides, and we end up with r squared equals 64. And then we want to undo the squaring part of that, so we're going to take the square root of both sides. And when we take the square root, again, don't hesitate to type that into your calculator or into Desmos. What we find here is that our radius is 8. And once we know the radius, then we go back, because ultimately what we're trying to do is we're trying to figure out, well, what is our volume of this one. So to figure out the volume, we're going to use our formula that's provided for us, but it's 1/3 times the area, oh, I keep doing that, area of the base times the height. But the area of the base is pi r squared times h. We can fill in what we know. We know pi. We just found the radius. Our height is 15. And I'm going to type in all of those numbers. I'm not going to type in the pi because it says leave your answer in terms of pi. 1/3 times 8 squared times our height, which is 15, gives us our value, also known as the volume, our volume being 320. And I need to go back and look and see what the units are. Meters. Oh, by the way, I got a typo on here. We got centimeters here. Let's go centimeters. So they're the same. So let's go centimeters cubed. But lastly, as long as we know the formula, we can, I hope, figure out the answer here. This time we know the volume of a cone, and we want to figure out the radius of this. So our formula is 1/3 pi r squared h, and fill in what we know. Once again, the cone has a volume of 108 pi. And the 1/3's not going to change. The pi's not going to change. We don't know r squared, but we do know that the height is 9. And we can simplify this right side of the equation if we multiply the numbers. So let's start by multiplying 1/3 times 9. And I hope you don't have to type it into the calculator, or I hope you don't have to type it into decimals. There's nothing wrong with checking your math. So we get 3. Over here on the right side, this is going to be 3 pi r squared. No more fraction to worry about. We've got our 108 pi over here on the left. I don't know why I wrote it in green. And now what we want to figure out is, what does r squared equal? So we're going to divide both sides by 3 pi. We're trying to get the radius by itself. And what happens is that the 3's cancel out. 3 divided by 3 is 1. Cancels out. Pi divided by pi is 1. So we're left with r squared over here on this right side. And on the left, 108 divided by 3 gives us 36. The pi's, pi divided by pi, they still cancel out. So now we've got 36. And then our last step to figuring out what the radius length is in a problem that we don't even have a picture for is that we need to take the square root of both sides. And when we take the square root of both sides, we get our radius that's 6, and our units are just meters.